Hello, and welcome to this video on alkanols. I am Arnold Villaro, and you can reach me at arnoldvillaro@gmail.com. Alkanols, also known as alcohols, are organic compounds characterized by the presence of the hydroxyl or OH functional group. They are referred to as alcohols due to their use in products like beer. The general formula for alkanols is CnH2n plus 1OH, where N represents the number of carbon atoms. The 2n plus 1 gives the number of hydrogen atoms. NOH is the functional group. Let's find the molecular formula for methanol. Using the general formula with N equals 1, we get C1H21 plus 1OH, which simplifies to CH3OH. Here you can see the molecular structure of methanol, showing the arrangement of carbon, hydrogen, and the hydroxyl group. The condensed formula for methanol is simply CH3OH. Next, let's look at ethanol. With N equals 2, the general formula gives us C2H22 plus 1OH, which is C2H5 oxygen monohydride. This slide displays the molecular structure of ethanol, illustrating the two carbon atoms and the bonded hydrogen and hydroxyl groups. The condensed formula for ethanol is CH3CH2OH. Moving on to propanol, with N equals 3, the molecular formula becomes C3H23 plus 1OH, resulting in C3H7 oxygen monohydride. Here is the molecular structure of propanol, featuring a chain of 3 carbon atoms. The condensed formula for propanol is CH3CH2CH2OH. Finally, for butanol, we set N equal to 4. This yields the molecular formula C4H24 plus 1OH, or C4H9 oxygen monohydride. This image shows the molecular structure of butanol with its 4-carbon chain. The condensed formula for butanol is CH3CH2CH2OH. Let us determine the molecular formula of pentanol. For N equals 5, the formula CnH2n plus 1OH becomes C5H25 plus 1OH, which simplifies to C5 hydrogen hydroxide. This slide displays the molecular structure of pentanol, showing the 5 carbon atoms and the hydroxyl group. The condensed formula for pentanol is CH3CH2CH2CH2CH2OH. The same process can be used to determine the formulas and structures for other alkanols, such as hexanol, heptanol, octanol, nonanol, and decanol. Alkanols are categorized into 3 types: primary, secondary, and tertiary alcohols or alkanols. A primary alkanol has the hydroxyl group attached to a carbon atom that is bonded to only one other carbon atom. In a secondary alkanol, the hydroxyl group is attached to a carbon atom that is bonded to 2 other carbon atoms. A tertiary alkanol has the hydroxyl group attached to a carbon atom that is bonded to 3 other carbon atoms. This slide illustrates the structural diagrams for primary, secondary, and tertiary alkanols. Considering physical properties, alkanols are soluble in water. Their melting and boiling points increase as the molecular size increases. Intermolecular forces and the density of alkanols also increase with an increase in molecular size. Finally, the viscosity of alkanols or alcohols increases as the molecular size increases. For chemical properties, alkanols react with alkali metals to produce alkanoates and hydrogen gas. For example, ethanol reacts with sodium to form sodium ethanoate and hydrogen. The balanced chemical equation for the reaction between ethanol and sodium is 2C2H5OH plus 2Na yields 2C2H5ONa plus H2. Alkanols also undergo combustion, reacting with oxygen to form carbon dioxide and water. For instance, ethanol plus oxygen yields carbon dioxide and water. The balanced equation is C2H5OH plus 3O2 yields 2CO2 plus 3H2O. Alcohols react with oxygen to form ethanol and water. This is a common reaction in the study of alcohol properties. The chemical equation for this reaction is C2H5OH plus yields CH3CHO plus H2O. Ethanol, a key alkanol, can be prepared in 2 main ways: fermentation of glucose or hydration of ethene. Fermentation of glucose is a process where sugar, like glucose, breaks down to form ethanol and carbon dioxide. The reaction for the fermentation of glucose is glucose yields ethanol plus carbon dioxide plus energy, or C6 hydrogen oxide yields 2C2H5OH plus 2CO2 plus E. This image illustrates the process of fermentation, resulting in the production of alcohol. The second method is the hydration of ethene. In this process, ethene reacts with water under specific controlled conditions to form ethanol. Here you can see a visual representation of the hydration of ethene reaction. The chemical equation is ethene plus water yields ethanol, or C2H4 plus H2O yields C2H5 oxygen monohydride. Alkanols like ethanol have several uses. They are used as fuel for motor vehicles and as a solvent in cooking. Ethanol is also an ingredient in medicine and is utilized in school laboratories and various industries. Furthermore, alkanols are the primary ingredient in alcoholic drinks. They are also used for making antiseptics, soaps, and wipes, and for treating poisoning by other alcohols. Excessive drinking of alcohol can lead to severe issues like car accidents, falls, burns, drowning, and increased job injuries and loss of productivity. It can also lead to poverty in families or communities and contribute to high blood pressure, stroke, and other heart-related problems.